So we can start with your question for the exam. Any question for the exam? Well, first, I will do for you an example I did for the other section because they asked me to do some practice about the condition number. So we considered the following matrix: 2, 1, minus 3, 4, minus 5, 6, 3, 0, 2. And the question was to find the condition number of this matrix. So if you want to find the condition number of this
Doctor,
matrix...
you are not sharing screen.
Oh, sorry, Yala, 1 second. Do you see it?
Yes.
Okay. So we were doing an example on the condition number. In case they ask you what is the condition number of matrix A, you should find A minus 1. Okay? And look, in general, if I don't, I will always specify for you how to get A minus 1. I can tell you to find A minus 1 using the calculator. If you want to use A minus 1 using the calculator, it's easier than doing LU factorization. Because when you use the calculator, what you will do, you will write, as we did together last time, if you remember, we said that the first column of A minus 1, okay, will be obtained by just solving for, if you want the following, we expect that A times A minus 1 is equal to the identity matrix, okay? So we can write 3 systems of 3 equations with 3 unknowns. The first system of 3 equations with 3 unknowns will consider that this matrix A, okay, times the first column. So if I do A, if I just do A times the first column of A minus 1, what do I get? Let us do it here. I will take A as it is. So I'll take matrix A here. And I will say I want to predict A minus 1 without using LU factorization. I want to use the calculator just for my calculator. My calculator is not a complex calculator. It just allows me to find the solution of a system of 3 equations with 3 unknowns. So if I take this matrix, then since I expect that A times A minus 1 will give me the identity matrix, then I can say the following: that if I take A and then I want to find the first column of A minus 1, I will call it V11, V21, V31. So I want to compute first the first column of A minus 1. I should expect that when I multiply A by this column, what do I get? What will be my result?
1, 0, 0.
Exactly, 1, 0, 0, which is the first column of my identity matrix. Okay, so when you write it like this is a system. This is 3 equations. I can write what are the 3 equations with 3 unknowns that I will have. So I'll obtain a system of 3 equations with 3 unknowns. And then I can say, if I introduce in my calculator offer for me the option to solve a system of 3 equations with 3 unknowns, all I have to do is to enter the coefficient in the following order as it is here. So you know your calculator, and when you solve a system of 3 equations, 3 unknowns, the first coefficient is for the first variable, the second for the second, the third coefficient you introduce is for the third variable, equals to the element on the other side of the equal, which is 1 here. Because if you want to transform this to an equation, the first equation you will get is 2 times V11 plus V21 plus 3V31 equals to 1. Okay, so this is equation number 1. Equation number 2 will be 4 times V11 minus 5 V21 plus 6 V31 equals now to the second term, which is 0. And what will be your third equation then? your third equation will be minus 3 v11 plus 0 v21. So you need, in case you want to use this option, or if I allow you, I tell you use the calculator, you should write the system of 3 equations with 3 unknowns and then solve for it. Okay, so plus 2 v31 equals to 0. So now,
دكتور
yes.
إذا فينا نعوز calculator وتقولي لنا بالسؤال you can use
ايه
a
اكيد
calculator.
اكيد بقولكم انا I will specify the method. Okay, the method will be very clear. Okay, so please stick to the method I ask for. So here, if I do so, I will have the following. I will have this is my system. Now I have my calculator. Try it. You introduce the coefficients in your calculator. Akid, you use it a lot. It's not the first time. Your calculator will give you the first 3 unknowns of a minus 1, which are v11, v21, v31. You will repeat the same procedure to find the second column. So to find the second column, you will write the same system, but now it will be v12, v22, v32, and then here you will, instead of 1 0 0, you'll get 0 1 0. Okay, so you find the second column, and to find the third column, then you say v13, v23, v33 equal to 0 0 1, and then so you have to solve for 3 systems of 3 equations with 3 unknowns, and then once this is done, you can give me all terms of matrix A minus 1. So if we apply this technique here, we will get the following matrix A minus 1. So this will be all elements of A minus 1, 2 over 12 minus 2 over 12, minus 3 over, 2 over 11 minus 2 over 11, minus 3 over 11, 2 over 55 minus 13 over 55, minus 3 over 55, and the last column, 9 over 55, 24 over 55, 14 over 55. So the first term you solve with your calculator, you will get these 3. The second time, the 3 unknowns you get will be the elements of column 2. And the third time, you will get the elements of column 3. And once this is done, you want to find the condition number. So now you want to find the condition number. So if I go back to my matrix here, how to get the condition number? I will specify for you which norm to use. So I will tell you use the summation norm, or use the summation column norm, or use the row summation norm. So if I ask you for the row summation norm, then you will move row by row and add the absolute value of elements. Please do not forget, in the norm, you take the absolute value. So here, for example, if I'm using row norm summation, I have for A, 2 plus 1, 3, plus absolute value of minus 3, so plus 3, it gives me 6. For the second row, 4 plus 5, 9, plus 6, 15. For the last one, 3 plus 0 plus 2, 5. And then I select the largest between these 3, which is 15. So I can write that the norm of A, according to the row summation, is 15. And you remember what is the symbol of it? What is the symbol of row summation?
norm بس من تحت بإنفينيتي.
Exactly. So for row summation, you represent it as A with an infinity symbol here. So A infinity is 15. I will do the same now to calculate row sum norm for A minus 1. So if I apply it on A minus 1, then I do summation of row elements here, 2 over 11 plus 2 over 55 plus 9 over 55, I get 21 over 55. I do the summation for the second row, minus 2 over 11, minus 13 over 55, 24 over 55, it's 47 over 55. And finally, minus 3 over 11, minus 3 over 55, 14 over 55, I get 32 over 55. And then the highest between the 3 is 47 over 55. So I can say that the norm of A minus 1, according to row summation norm is 47 over 55. And now all I have to do to find the condition of my matrix A is to multiply the norm of A minus 1 times the norm of A, and then I will get 12.81. This means that what is the index of this? How it can help me? This will give me the degree of illness of my matrix. What do I mean by degree of illness? If you remember, when we said that if we want to use matrix A to solve a system, if I have, for example, if I have A times X equals to B, and I want to solve for X, if, for example, in B I just provide 4 digits, all my numbers are provided with an accuracy of 4 digits, okay? Then I can expect what will be the error induced in X. How I do this? Let's say for B elements, I have, for example, 12.92. So I'm using 4 digits for B elements. Then now, when I set, in order to know how many digits I should disregard when I find X, I should find T minus T. T is the number of digits in B or A. Yani, this is because when you do the operation, it can be in A or in B. This is valid for both. Okay. So I'm using 4 digits. Then I have that. I should compute what is C to know what is the number of digits that I can disregard. Okay. So here, if I want to calculate for C, all I have to do is to do log base 10 of the condition number. And here, since it's higher than 10, then you will get 1 point something. So C will be equal to 1 point something. So it's between 1 and 2. This is why in the worst case scenario, you should disregard the last 2 digits of your X solution. So let's say if you obtain for X1 21.92, for example, you say I will disregard these 2. I cannot trust them. So I can just trust the first 2 digits. So this is why we say that we can trust 4 minus 2 in the worst case scenario. I might have cases that are better, but to be on the safe side, I should know what is my worst case scenario. My worst case scenario, I cannot trust the last 2 digits here. And if B was given with 5 digits, let's say it's 12.921, and I got X1 equal 21.923, then I can just look at the first 3 digits because I will disregard the 2 last ones. Okay? Any question on this? Now, if they tell you find the norm using the column norm summation, same procedure, but now you sum elements of columns. So here, 3 plus 4 plus 2, it's 9. 0 plus 5 plus 1 is 6. 2 plus 6 plus 3 is 11. So I can say that now notation is norm subscript 1. So this is for column summation is equal to 11 for A. And for A minus 1, I will also do the column summation. So here I have 2 plus 2 plus 3 over 11, which is 7 over 11. 2 plus 13, 15 plus 3, 18. So it's 18 over 55. And for the last column, 9 plus 24, 33, plus 14, 47. So I have 47 over 55. It's clear that the third column has the highest summation. So it's the norm. So I can write that the norm of A minus 1 with respect to column summation is 47 over 55. So I can now find what will be the resulting value of A times the norm of A times the norm of A minus 1. It is close, but little bit lower. Yani, when I calculate the norm, it's 9 point something. So in general, we take the worst case, the largest condition number to be on the safe side. But I will be specific for you, and I will tell you to use the row or the column summation. Okay. Any question on this?
Doctor, did you decide is a 5 or 4 problems?
مبدئيا four problems. هلا true or false I will increase the number شوي. true or false, just believe me, if you just understood the concept and if you understood what I am telling you in class, you will do them very well. يعني. It's like same. هلا هن whole chapters are not very tricky as the first ones. So I expect إنه you will do better in true and false this time. يعني مثلا إنه I can ask you, is Gauss better or naive? So of course Gauss elimination is better than naive elimination. So you should know the characteristics of each method. You should know in which case it's better to apply it. So this is how it, this is the context of questions. And if you have small details, sometimes I give you some notes about something. So any note that is given in class and repeated several times can be used in true or false questions. Yes, one additional thing I want to tell you. Just let me erase. In the exam, I will represent the matrix in a table because using Blackboard, I was not able to introduce a matrix. So I will tell you how I did it. So for example, if I have a times x equal to b, I represent it in this way. I put a table like this. Let's say I have 3 by 3, okay? I put the elements of my matrix, so 1, 3, 2, I fill it. Here I tell you, in this column, I don't put anything. I put multiplied by. I put here, let's say, x1, x2, x3. And I put here equals to, and I put b vector. So just, this is the way I presented them for the exam, okay? So, but they are clear. No, this is A, this will be A. This is X, and the last column will be vector B, okay? Just to tell you to not be confused. If you
دكتور بس لنلاقي x1 و x2 و x3 we sum them ونحطهم
حسب الكويستشن. في question يمكن بس اطلب منك x1 او بس x2 او بس x3. في questions please كثير اقروا منيح الكويستشن please. Don't directly start. إذا قريتوا تشولسكي ما تعملوها كلها من دون ما تقروا الكويستشن. Okay? أو if you read find the inverse ما تعملوها كلها لأنه this will take a lot of time. Please take 10 seconds. It needs 10 seconds of concentration to know what you need to find exactly. يعني أنا يمكن أطلب بالinverse one column. وبقول لكم find the summation of elements of this column. Please انتبهوا إذا first أو second أو third column. Okay? So please read well the question. ما حدا يقول لي ما انتبهت. Please pay attention for this. I cannot count it right إذا عملتوها غلط. Okay?
دكتور
Yes.
إذا قلت لنا تبع 1 column نستعمل اليو أو الكالكوليتر؟
أنا ححدد الميثود. على طول ححدد لكم أي ميثود تستعملوا. Okay?
ودكتور نحن بالنورم سوري.
Yes.
نحن بالنورم بالماتريكس ما عندنا نورم 2 وهيك ما هيك بس ال1 والانفينيتي.
لا بس ال1 والانفينيتي.
اوكي ميرسي.
Any other question?
كيف ممكن يوجد true false؟
نعم.
كيف ممكن يوجد true false؟
ما هلا قلت كيف ممكن يوجد. هلا بعدني قلت. For example, فيني أسألك is naive Gauss elimination better or Gauss elimination? For example, true or false? هيك قصص. You should know characteristics of methods. You should know which method we should use at which time. Okay.
Okay, dear, thank you.
Any other question?
I have two questions.
Yes, tell me.
أول شيء بس تقولي لنا بالإكزام إنه استعملوا تشالسكي we don't have to prove that it's positive definite بقى صح؟
Exactly. No, you don't have to prove.
Okay, my second question كمان بتشالسكي إنه إذا نحن عم نلاقيها إنه عم نعمل LU factorization دايما it's the upper transpose times the upper or lower times lower transpose مش بالقلب.
أكيد. لأنه أصلاً ما هي هي final purpose is to decompose A into L times U. يعني بالاخر مثل بالاليو factorization you were able to get a lower times in upper. هون كمان حيكون عندك a lower matrix times in upper matrix بس with different elements.
Okay, thank you.
Well, any other question?
بس دكتور انا قلت لك عندي questions.
Yes.
بدي اسالك دكتور addition و subtraction تبعوا الماتريسز عندنا شيء انهم
Addition لا addition and subtraction of matrices no.
يس
No.
اوكي لانه بالبوك شفت في اكسرسايز كان محطوط بس
No. ما هو في لأنه في هيدا البروجرام كتير كبير ما بنقدر to cover everything in the book.
اوكي يس. ودكتور بعد شغله لما نحن جبنا اول شيء الانفرس قلنا انه لازم تكون سكوير الماتريكس، يعني بحال مثلا ما كانت سكوير ما بنقدر نجيب الانفرس.
Yes. ما فينا بدها تكون square matrix. Yes.
اوكي.
Okay.
يس وبالنسبه لل
وكمان بده يكون الديترميننت تبعها different than zero. إذا عندك determinant zero you
Yes.
cannot find the inverse.
ما بنقدر.
لا.
يس.
أصلا إذا جربت بيطلع لك إنه impossible. ما
يس.
بتزبط.
ما بتزبط معي. يس.
Mahdi, yes, of course you have Kramer rule. Okay. And in LU factorization, I will specify for you, but yes, you should do pivoting. Ralph, you are asking about what? For A minus 1, you mean?
خلاص جات سألتك بعدين.
Okay. Any other question?
يس دكتور.
Yes.
بالcondition في كان بالdefinition عن الerror إنه less than or equal than condition of A times the norm of A over norm of
Yes.
هيدي نحن وقتها قلتي عن نوت إنه لما تكون the minimum إنه تكون هي equal.
الworst case scenario بتكون equal. worst case scenario. Okay. فيها تكون smaller error بس الworst case scenario إنه equal.
اوكي يعني مثلا نحن اذا كانت الورست كيس سيناريو مثلا 2 digits نحن فينا مثلا نزيد مثلا ل 3 or 4.
ايه فيك تقول انه بس ما فيك تكون اكيد منهم، يعني فيك تاخذ اذا بدك انت قصدك انه to disregard 3 or 4.
لا مش disregard اخذ digits
يعني انت قصدك انه بدي اخذ حتى هول الديجيتس اللي ما لازم اطلع فيهم بدي اخذهم.
يس الباقيين
تاخذهم بس بيكون عندك ريسك، لازم تعرف انه عندك high risk. Sometimes it will work with you, okay, but sometimes it will give you a completely different result. يعني it can be misleading for you.
يعني هي السيف سايد تبعت الورست كيس سيناريو.
Yes, of course. يعني أنت to be on the safe side كل ال T minus C it's garbage. You don't look at them.
Yes. last thing regarding Cholesky إذا مثلا كانت 4 by 4 matrix بس بنزيد الرو والكولم الزايد وبنعمل نفس الشيء بالنسبة لليو بس بالأكيد زيادة elements.
نفس method of course.
Yes.
نفس concept. ترجع to go back to the definition إنه A times إنه L times U هيدا ال upper transpose times upper is equal to identity matrix.
Yes, exactly. Thank you, doctor.
Welcome. Any other question? Okay, guys, good luck for tomorrow. If you have any other questions, you can ask me on WhatsApp. Bye-bye.
Bye, doctor.